Hello folks, so in this video we're going to talk about horizontal and vertical lines and how we can find their slopes and also their equations. So let's start off by actually just drawing horizontal lines. So we'll focus on horizontal, then we'll go to vertical lines. Okay, well here's a horizontal line, so I'll draw my axes here. Now let's suppose I have this horizontal line that just goes across right here. You'll also notice that I'm using high contrast mode. There is no particular reason for this. I just wanted to try something different. So let's suppose that this line, so it's quite reasonably horizontal again. So I'll mark off this point right here. This point would be 1, 3. Let's see, this point over here would be 4, 3. And this point over here would be, I don't know, negative 2, 3. So let's say we want to find the slope. Well, just like it was before on any non-vertical or horizontal line, we just need to find 2 points. So I'll use this point right there and that point right there. Well, okay, so the slope is, as usual, it's going to be rise over run. Rise over run. So let's see, my rise, my delta y would be, well, let's see, let's suppose I start off right here at 1, 3, and I'm going to end at 4, 3. Okay, well, my rise would be, well, I start off at 3, and I go to 3. So that would be 3 minus 3. For our delta x, I would be going from x equals 1 to x equals 4. So I'd be moving over, I think, 3 units. I can show that by doing 4 minus 1. This, once we clean this up, is going to be 0 over 3, which is just 0. Okay, well, just for the heck of it, what if I instead tried using these other points? Oops. Apologize for that. Let me change this real quick. What if I wanted to do this one as my starting point here? Okay, well, if I did that, then my slope again, delta y over delta x, delta y would still be from 3 to 3. And then my delta, sorry, that was my delta y, excuse me. My delta x then, we're going from negative 2 to 4. So let's see, 4 minus negative 2. Just keep track of that negative sign. You'll get 0 over 6, which is still 0. And that should make sense, actually, because we talked about how, depending on, the only thing that matters for your slope is what your line is. This is the same line, so no matter what 2 points I use, the slope should be the same. So it turns out the slope is 0. And this should actually make sense, because if you're on a, let's say, a level surface, you're on, walking across your room, hopefully your room is flat, then you're not going up or down at all. You're just going to go straight to the right. Or if you're going backwards, you go straight to the left. And so actually, the slope of a horizontal line, is 0. And that's something we're going to want to put in a nice box with stars on the side. And the reason that's the case is because if you are horizontal, then your rise over run, your rise is always 0. And so it's going to be 0 over whatever your run is. It doesn't matter what your run is. You could keep going to the right 7 units. You could go 7,000 units. If the ground is horizontal, or the line is horizontal, excuse me, you're not going up at all. So no matter what you run, 0 divided by that number is still going to be 0. So now that we know the slope of this line, let's actually take a look at our equation. Well, remember, our equations have always been so far y equals mx plus be, although actually now that I think about it, we haven't actually used this terminology yet. It has so far been y equals the growth rate, or the slope, times x plus the starting value. Starting value or figure 0, however you want to think of it. Now, in this case, we actually have both of these pieces of information. So our growth rate, remember, in this case, if it's horizontal, is 0. And in this particular scenario, our y-intercept, well, if we keep just running across, well, the y value should still be 3. It's 3 here, it's 3 here, and it's 3 here. So it doesn't change at all. So it must be 3 when we get to the y-intercept. So that would mean that our equation is simply y equals 0x plus 3, or just, because 0 times anything is just 0, turns into y equals 0. So this one's interesting because it doesn't have x in the equation at all. But let's think back to what a graph, actually is. We've talked about graphs for a while now, and this is something we kind of forget sometimes because you just take it for granted. Points on a graph just tell you x and y values that make the equation true. Make the equation, the equation true. Now think about this. If I'm looking over here at this horizontal line, what is true? Well, the x values on the points that I pointed out anyway, they seem to be kind of just random here. Seem to be kind of random. Oops. Because I just used negative 2, 3, 1, 3, 4, 3. But there's also this point right here, which would have been 3, 3. Way down over here, there's going to be 6, 3, and so on. So if the x value can be kind of anything, but the y value stays the same, then the only thing that seems to be a requirement to be on this line is that your y value is 3. So even if I keep going way down there, eventually there's going to be something like negative 999, 3. And so that's why this graph right here, I said y equals 0. I meant to say y equals 3. I apologize. So that is the equation of a horizontal line. We could take one more look at an example here. If I have a horizontal line right here, not too crazy. Maybe this one is down here at, it's horizontal and it passed through this point. Let's say that point right there is, let's not do that actually. Let's do this one. Let's say that this point right here is negative 3, negative 4. Well, if it's, again, horizontal, which it sure looks like it, I would say that the y value is 0x plus negative 4, because my starting value right here, that would be at 0, negative 4. And so my equation, once I clean up this part, is simply y equals negative 4.